So today we'll start the second chapter, that is chemical reactions. Okay. So in this chapter, I think you all know what are the types of chemical reactions, basic types of chemical reactions. What are they? Yes, Ajay, what are the basic types of chemical reactions? How many reactions, types of chemical reactions are there?
Combination,
double displacement,
Basically,
displacement
there
and
are
double
four types.
displacement.
Yes, direct combination, decomposition, displacement, and double decomposition. Okay, or double displacement, we can say. So in this chapter, we learn what is a chemical reaction, how to represent the chemical reaction, and characteristics of chemical reaction. Characteristics means indication. What are the visible characteristics? How can we identify whether a chemical reaction has taken place or not? And the next one will be types of chemical reactions. Here we learn each and every reaction in detail and the energy changes which happens in the chemical reactions. Okay. And last one is conditions for chemical changes. If a chemical reaction has to happen, what are the conditions required? We know that each type of reaction require each different reaction conditions. So we'll summarize all the reaction conditions which are required during a chemical reaction. Yeah. So first, coming to definition of chemical reaction or a chemical change, we all know that a matter changes from one form to other form. We cannot say that it is state of matter, but the matter changes into a new substance. We can specify it as it changes into one or more new substances, right? So it is all the chemical reactions you have learned in your 7th standard, right? Physical change and chemical change, right? So all the chemical reactions are chemical changes in which matter changes into a new substance, one or more new substances. So how to represent a chemical reaction? I think no need to explain this one, how to represent a chemical reaction, right? How will represent? On the left hand side, what we will write?
reactants,
On the left hand side we will write reactants, and on the right hand side we will write products, and they are separated by
arrows,
they're separated by an arrow, right? And
Excuse me, ma'am.
Yes, Toshit. Yes, Toshit.
Ma'am,
Yes.
copies for this.
Sorry.
He's asking that can
You
we
send
should
for
copy this.
No need to write it down.
No, ma'am, I am asking that would you send scanned copies?
Okay, scanned copies I'll send. For periodic table and this chapter I'll send the scanned copies.
Okay.
Okay. Yes. So we
Ma'am,
all know
your
that
voice is echoing.
my voice.
Ma'am, could you please mute everyone?
Yeah, I'll do. Yeah. Yes, I have muted everyone. Okay. So we all know that the chemical reaction is represented by chemical equation. That equation contains reactants on the left hand side, products on the right hand side, which are separated by an arrow. And we have to balance the chemical equation. Why? What is the need to balance the chemical equation? What is the need to balance chemical equation?
Ma'am, law of conservation of mass.
Very good. According to the law of conservation of mass, we have to balance the chemical equation, because according to law of conservation of mass, during a chemical change or during a chemical reaction, matter can neither be created nor be destroyed, but it changes from one form to another. In order to show the law of conservation of mass, we have to balance the chemical equation. And in your 8th standard, you have learned what are the different things to modify the chemical equation in a better way, right? What are they? We have to write the state of matter of the reaction, whether it is solid, liquid, or gas. And we have to write it the reaction. Reaction, if it is reversible reaction, we will write the arrow as double-headed arrow, right? So all these, if it is aqueous solution, we'll write in the bracket aqueous. If it is precipitate, how do we represent the formation of precipitate?
Down-headed
PPT
arrow.
or the down arrow.
Down-headed arrow, right? So all these are the modifications ought to clearly represent the chemical reaction by a chemical equation. Okay, now coming to the characteristic properties of a chemical reaction. Characteristic properties are, as I told you, indications. That is a visible change. How we can identify whether a chemical reaction has happened or not. It is all through these 5 changes. Basically, these 5 changes represents or indicates that a chemical reaction has taken place. First one is change in color. And second one is change in state of matter. It also shows the formation of or the indication of chemical reaction. And third one is evolution of gas. If gas is evolved, how to represent in the equation?
Arrow pointing upward.
Yes, up-headed arrow, it is the evolution of gas. And formation of precipitate and evolution or absorption of heat. What are those reactions which proceeds by evolution of heat?
Exothermic and
Exothermic
endothermic.
reactions, right? Exothermic reactions are the reactions which proceeds through evolution of heat, whereas endothermic are the reactions which proceeds through absorption of heat. We can easily identify whether the heat is released or heat is absorbed, right? So all these are the indications, visible changes through which we can confirm or which we can identify that a chemical reaction has taken place. Clear? Right. Next, coming to types of chemical reactions. As we have mentioned, there are 4 basic types of chemical reactions. First one is direct combination reaction. That is, 2 substances react to form a new one product. So here you have to understand, in direct combination reactions, one will be the major product. That means we can say only one product is formed. How many ever may be the reactants, only one product is formed. So the first direct combination, how can we define direct combination reaction? The reaction in which two or more substances combine to form a single product, or 2 or more reactants combine to form a single product. That is how we define direct combination reaction. Whereas decomposition, it is a single reactant decomposes or splits into 2 or more products. Right. Whereas displacement reaction, what is displacement reaction? One reactant displaces or replaces other reactant, generally from its solution. So we'll discuss clearly later, but one thing you understand, in displacement reaction, if a substance has to displace or replace another substance, there should be a solution, there should be a medium which is a liquid medium. So we generally define displacement reaction as a substance or a reactant displaces or replaces another reactant from its solution. So you cannot simply write as one substance replace another. You have to mention from its solution. It is called as displacement reaction. Whereas double decomposition, it is also called as double displacement. Both the reactants replace from their solutions. Such type of reactions are called as double decomposition or double displacement reactions. Clear?
Ma'am,
Yes.
ma'am, in this double decomposition reaction, the interchange of this also happens. No, the signs means that positive becomes negative one.
Yes, that is ionic substances.
Yes.
Right? In generally, displacement reaction takes place in ionic substances, ionic compounds. Right? For example, if I take NaCl and let us suppose FeSO4. Okay, or for simple, you can take NaCl plus H2O. Right? It will form NaOH plus HCl. So both the reactants will displace. So it is generally seen in ionic compounds. Good. Is it clear? So we can see the examples. That is direct combination. The two reactants combine to form a single product. Decomposition reaction, a single compound, it will decompose into two products. I think you all are familiar with this decomposition reaction. Right, in your 8th standard, we have discussed
Yes.
compounds, calcium
Yes, ma'am.
carbonate. Right?
Ma'am, is this reaction reversible?
Yes, calcium, this reaction is reversible. The decomposition
Okay,
of
ma'am.
calcium carbonate is reversible reaction. Whereas single replacement or displacement reaction, generally for displacement reaction, you all should be thorough with the activity series. The more active metal only can replace the less active metal from its solution. I think you have learned this in your 8th standard, right? So more active, more reactive metal replaces the less reactive metal from its solution. Whereas the next one is double displacement, or sometimes it is also called as double replacement reaction, in which both the reactants replace one another. Clear? Right? Yes. So tell me, Uttirna, tell me what are the 4 types of chemical reactions? Yes, Uttirna, tell me what are the 4 types of chemical reactions? Yes? Can you tell? Can you tell or no, Uttirna? Are you listening to any video?
Ma'am, you might be listening to some video or something.
He's waving his hand. No, ma'am. Tell me, Uttirna, what are the 4 types of chemical reactions? Okay, I can't hear him.
Ma'am, his mic doesn't work.
Okay, Mehak, tell me what are the 4 types of chemical reactions?
Yes, ma'am. Ma'am, the first one is direct combination, decomposition, displacement, and double displacement.
Double displacement. Good. These are the 4
Ma'am,
types of.
could you take the page back?
Why?
Ma'am, I wanted to write the examples.
No need to copy down the examples. I'll give you the examples in the when we discuss each and every type of reaction. So first one, direct combination reaction. Today we'll discuss in detail about this reaction. So in direct combination reaction, as we have discussed, the 2 or more reactants, they will combine to form a single product. Generally, the direct combination reaction is also called as synthesis reaction. If you remember, photosynthesis, all the synthesis reactions, synthesis means formation, right? All the synthesis reactions are combination reactions. So in the exam, they may ask you as combination reaction or synthesis reaction. Both are same. Clear? Right. So if we see the different formations or different direct combination reactions, two elements can combine to give a single compound. Can you give any example? Yes, Advut, can you give any example? Two elements combine to give a single compound.
And Na plus Cl gives NaCl.
Na plus Cl2. Cl exists as
Yes,
chlorine gas,
yes,
right?
Cl2.
Na plus Cl2 gives NaCl.
NaCl.
Ma'am, H2 plus O2 is equals gives H2O.
Yes, hydrogen plus oxygen gas react to give water. Any other example?
Mg plus Cl.
Mg plus Cl2 we have to tell. Chlorine
Sorry.
exists as chlorine
Chlorine
gas,
gas.
Cl2 molecule, right? Yes.
Mg plus Cl2 is MgCl.
Mg plus Cl2 gives MgCl2. So, one type of combination reaction is two elements combine to form a compound, a single compound. It may be ionic compound or it may be a covalent compound. Hydrogen gas and chlorine gas combine to form hydrogen chloride, HCl, right? Next, there are some another type of chemical reaction, combination reaction is element combines with a compound to give new compound. So this is a second type of combination reaction, whereas element will combine with compound. Can anyone give example, Neo? Can you give example for this one? Element plus compound.
Ma'am,
Yes, Aditya, can you give the example? Think element combines with
Ma'am?
the compound. Yes, Rohan.
Ca plus OH equals CaOH twice.
No, OH does not exist. OH is a radical.
Okay, ma'am.
It does not exist, right? Yes, carbon monoxide plus oxygen. Carbon monoxide is a compound, right? Oxygen is an element. It's a molecule, right? So carbon monoxide plus oxygen, we will get, what do we
Carbon
get? Carbon
dioxide.
monoxide plus oxygen.
Carbon dioxide.
Carbon dioxide, right? So carbon monoxide plus oxygen, we will get carbon dioxide. So anyone, did you get any other examples?
Water plus hydrogen.
Water plus hydrogen, nothing is
Sorry. Water plus oxygen.
water plus oxygen, what we will get?
H2O2.
Okay. But generally that reaction doesn't occur in normal conditions. Yes, that is also one of the reaction. Water reacts with oxygen to give hydrogen peroxide. Yes, anyone can tell any other examples?
And CO plus O2.
CaO plus O2. CaO plus O2, what do we get? What is a product?
CaC. No. Sorry.
No, that reaction doesn't happen. A compound plus element. The best example which you all know, it is carbon monoxide plus oxygen gives carbon dioxide, and water plus oxygen gives hydrogen peroxide, like that. Okay, and you can take all the oxidation reactions. Sulfur dioxide plus oxygen, we will get sulfur trioxide. Nitrogen oxide plus oxygen, we will get nitrogen dioxide. Okay, right. Next, a compound combines with another compound. So this is the third type of combination reactions. I think for this you all can give the examples, right? Give me one example, compound plus compound.
NH3 plus HCl equals ammonium chloride.
Yes, ammonia plus HCl gives ammonium chloride. And the example which was written here as well. Calcium, this is a reversible reaction we can take, right? Calcium oxide plus CO2. Calcium oxide plus carbon dioxide gives calcium carbonate. Any other examples, girls? Kavya is there?
Yes, ma'am.
Kavya, can you give an example for a compound combines with a compound? Can you give a reaction example? Okay, fine. Yes, can you give? Yes, Ashraj, can you give the examples for that? Compound combines with compound. Examples for that.
I don't know.
Okay. Yes, Pranjal.
Ma'am, CO2 plus H2O, H2CO3.
Very good. Water plus carbon dioxide gives carbonic acid. That we'll discuss there. All these examples we'll discuss now. Okay. So there are three types of combination reactions. The first one in which two elements combine to form a compound. Second one, element combines with compound to form a new compound. Whereas the third one is two compounds will combine. Clear? So the first one we will discuss with element and another element. Element combines with element. Okay. So that is the basic example. The main example is oxidation of metals and non-metals. So children generally understand this one. Any substance, any element we have discussed in periodic table, any element when it reacts with oxygen, it will form oxide. I repeat, any element when combines with oxygen, it forms oxide. It may be metal or a non-metal. If metal reacts with oxygen, we will get metallic oxides. If non-metal reacts with oxygen, we will get non-metallic oxides. Is it clear? Did you get my point? So can we say this is the example of combination between element and an element? Right? The first type of reaction, element combines with element to form a compound. So do you all agree that formation of oxides is a combination reaction? Metals, you can see all these metals react with oxygen. So these are generally called as binary compounds. Children, binary compounds means which contain two elements. Clear? So all these are the binary compounds. The formation of binary compounds is one of the example is oxides. Element plus oxygen. No other element will be, no other substance will be present. Just reaction between, a simple reaction between element and oxygen is an example of binary compound, formation of oxides. Clear? So we know that all these oxides, we can write the formula based upon the crisscross method, based upon the valency. What is the valency of oxygen?
2.
2. Right now, can you all complete these reactions? Sodium plus oxygen, sodium oxide. The name will be the element plus oxygen, that oxide, metallic oxide and non-metallic oxide. Calcium plus oxygen, calcium oxide. Magnesium plus oxygen,
Magnesium
magnesium
oxide.
oxide. Right? So complete these equations. Complete these equations, all of you. The first example for the combination reactions is formation of oxides. Oxides are the binary compounds which are formed by the reaction of oxygen with metal or non-metal. Metals form metallic oxides and non-metals form non-metallic oxides. We will even discuss the properties of these metallic and non-metallic oxides. Complete the reactions. Ajay, are you able to follow? Okay, complete these reactions.
Ma'am, can you
Don't
show
tell me
previous
orally,
slide for 1
complete, write
minute?
it in your notebook.
Ma'am, can you show the previous slide for 1 minute?
This one, direct combination reactions.
That
Yes,
ma'am, the one before this.
yes. Complete these equations. Arya, are you writing down? Arya? Arya, are you writing down?
Ma'am, done.
Yes, ma'am.
Good. Yes. Tell me the second equation, Priyadarshini. Second equation, calcium plus oxygen.
CaO. Ma'am, 2 CaO.
You have to balance, children. Any chemical equation, make sure even if it is mentioned or not, you have to balance. It will be 2 CaO, calcium oxide.
And
Right?
ma'am, you
Hope
had
you all got this? Yes. Magnesium plus oxygen, Ishwari.
M2 mg.
mg
2 mg.
2
2 MgO.
O2.
Right? Magnesium oxide. Yes. Ferrous, I have mentioned it is valency is 2. Ferrous plus oxygen. What do we get? Yes, Ajay.
feo
FeO.
FeO. Very good.
2
If it
and
is
2 FeO.
Fe3,
Fe3 then Fe2O3.
very good. We'll get Fe3O. Sorry, Fe2O3. Ferric oxide. Then coming to non-metals, sulfur plus oxygen. Yes, Neo.
SO2 SO SO2
Ma'am,
Yes,
SO2.
SO2. All the non-metals, we generally give the name as the number of the elements also. Sulfur dioxide. If it is SO2, we'll write it as sulfur dioxide. Right? Yes, sixth one. Carbon plus oxygen. Uttirna.
CO2
Uttirna. Carbon plus oxygen. What do you get? Yes, Uttirna. What do you get? Carbon plus oxygen. Carbon dioxide. Just you have to combine these elements and form the compound. It is a combination reaction. Just the element and element will combine to form a compound. Yes. Phosphorus plus O2. Yes, Aditya. Phosphorus plus O2.
PO2.
What is the valency of phosphorus?
3. P2O3.
P2O3, or it also forms P2O5. Phosphorus trioxide or phosphorus pentoxide.
Pentoxide.
Ma'am, can I tell the 8th one?
Yes. Yes, Manas.
H2.
H2O2.
Huh?
No. Hydrogen
H2O.
gas combines with oxygen gas to form water molecule.
2H2O.
2H2O.
2H2O. 2H2 plus O2. 2H2O.
Corrected, it is not H2O2, it is 2H2O. Water molecule you'll get.
Ma'am, one more example for that compound reaction is CaO plus H2O, which gives
Yes.
CaOH twice.
Very good. Calcium oxide reacts with water to give calcium hydroxide. Good. Clear? So these are formation of oxides. So here I want to mention one more point. Children, if the element reacts with oxygen, we are discussing that we form oxides. In the same way, a binary compounds in which element react with hydrogen, they are called as hydrides. I repeat, binary compounds of element and hydrogen, we will get hydrides. Okay. Whereas element plus nitrogen, binary compounds of elements and
Nitrides.
hydrogen, we will get
Nitrides.
nitrides. Clear? So all these examples
Yes,
are
ma'am.
all these reactions are examples of element plus element combination reactions. Formation of oxides, formation of nitrides, formation of hydrides. Right. Now, next coming to the properties of these oxides. All the metallic oxides, we generally call them as basic oxides. If you remember, metallic oxides, metals are basic, non-metals are acidic. We have discussed in periodic table, right? Metals are basic and non-metals are acidic. So one of those reactions is metallic oxides. When they react with water, they form bases. Generally, they form hydroxides. And non-metallic oxides, when they react with water, they form acids. Because non-metallic oxides are acidic in nature. So this is one type of combination reactions. What is that? Metallic oxides react with water to give hydroxides. Hydroxide, the bases which are hydroxides, they are also called as alkalis. Right? We have discussed in periodic table. Alkali metals, alkaline earth metals. Right? The substances, the bases which are dissolved in water. So metallic oxides, when react with water, they form hydroxides. They form bases. So if you remember the basic statement, you can easily form the reactions. You can easily write the reactions. Vijay, are you able to follow? Some of the students felt difficulty in 8th standard in this chemical reactions. So what is the general statement? Metallic oxides react with water. They always form hydroxides, that is bases. Whereas non-metallic oxides, when they react with water, they form acids. Sulfur dioxide, when reacted with water, it forms sulfuric acid or sulfurous acid. Carbon dioxide with water, what is the name of H2CO3? Carbonic acid. Whereas phosphorus oxide with water, we will get phosphoric acid. Nitrogen dioxide and water, we will get nitric acid. Clear? Are you all able to follow? So, non-metallic oxides, when reacted with water, we will get acids. Clear? Okay. Now, coming to metallic oxides, when reacted with water, they will give bases, that is hydroxides. So I gave you one equation. Complete this equation. Zinc plus oxygen. The valency of zinc. In first chapter we have learned. What is the valency of zinc?
2 plus 2.
Plus 2. Right. Zinc plus oxygen is, yes, complete that equation.
ZnO2.
What is the valency of oxygen?
And ZNO.
Oh yeah, sorry.
Right. What will be compound A? Zinc plus oxygen will be zinc oxide,
Zinc
ZnO.
oxide.
Right? Zinc oxide plus water, what will be B?
Zinc hydroxide.
Very good. Zinc hydroxide, ZnOH twice. Because hydroxide valency is -1. Clear?
Yes, ma'am.
Is it clear? So these are the different combination reactions. Remaining reactions we'll discuss today because it is already 9:40. Okay. Is it clear, children? So today we
Yes,
have
ma'am.
discussed
Yes.
Ma'am, what element is NO?
NO is nitric oxide. It is compound.
Okay, ma'am.
Nitric oxide.
No, because O is written in
Ma'am?
small.
Yes.
Ma'am,
Yes,
does
Rohan.
does oxygen show variable valency, ma'am? Like sometimes plus
No.
-3?
No. Oxygen does not show
No, ma'am?
variable valence. It always show -2. Whereas nitrogen shows variable valency. Phosphorus, the 15th group elements, nitrogen, phosphorus, they show variable valencies. Oxygen never shows.
Ma'am, how is NO2 formed then, ma'am?
NO2 form. NO2 is a covalent compound.
Okay, ma'am.
Okay, so that it will be formed with a nitrogen valency is 3. With one oxygen, it forms a single bond, and with other oxygen it forms a double bond. So NO2, there will be 3 lone pairs of electrons on oxygen, because one oxygen forms only single bond with nitrogen.
Ma'am, and what will be the portion for the IA in the test?
Assessments we have already discussed, right? First chapter,
Oh my God.
language of chemistry, and fourth chapter, atomic structure and chemical bonding.
Okay.
Is it clear? So today we have discussed direct combination reactions. I'll give some more examples in the next class. Okay, then we'll proceed to the second type of
Okay, ma'am.
reaction. Clear? Any doubt, children?
Ma'am,
Yes, Rohan.
Thank you, ma'am.
ma'am, could you send the pages of language of chemistry, ma'am?
Okay, language of chemistry you want me to say. I have sent you the valency chart, right? I'll send you the pages also. The scanned
Yes, ma'am.
copy also I'll send. Is it clear, children?
Yes, ma'am.
Any doubt?
Yes, ma'am.
Yes, ma'am.
No, ma'am.
Okay, fine.
Thank you, ma'am.
Okay, I'll just take your attendance. Please give your attendance. Yes, Erlin,
Yes, ma'am.
Arya, Arya, you're absent yesterday. Sorry, day before yesterday, I think. Abhigyan,
Yes, ma'am.
Amay,
Yes, ma'am.
Yes, ma'am.
Aishwarya,
Yes, ma'am.
Aditya,
Present, ma'am.
Advut, Chesta, Ishwari,
ma'am.
Ishwari,
ma'am.
Gunit,
Yes.
Girija.
Present, ma'am.
Girija, did you understand any confusion?
No, ma'am.
Kashish? I saw Kashish, okay. Kavya?
Present, ma'am.
Kashish, how are you?
Present, ma'am.
Ma'am, I'm good.
Okay, Kushi,
Present, ma'am.
Krishna,
Present, ma'am.
Mehak, Manas,
Present, ma'am.
Manas,
Present.
Neo,
Present, ma'am.
Neha, Ojay,
Present,
Oves. Oves, are you there?
Ma'am, he was there. Just now he got disconnected.
Okay, Preksha,
Yes, ma'am.
Priyadarshini,
Yes, ma'am.
Pranjal,
Yes, ma'am.
Rohan,
Present, ma'am.
Riya,
Present, ma'am.
Shivam. I think Shivam is absent today. Yes. Samiksha,
Present, ma'am.
Taushit, Uttirna,
Present, ma'am.
Yashraj, Ayman.
Yes, ma'am.
Okay, good. So, okay, children will meet in the next class. Okay, thank you.
Okay, ma'am. Thank you,
Thank you, ma'am. Goodbye.
Bye.